Opening. In this video, we focus on AI models, what they are, how they differ, and how to choose the right model for the right task when learning in academia. Key idea: when you use an AI feature inside a tool, for example, a writing assistant or a PDF helper, you are usually calling a specific model through a limited, pre-built application program interface, or API workflow. Understanding the model layer helps you understand what the tool can and cannot do. By the end of this video, you should be able to describe what a model is, recognize the most common model attributes you'll see in product menus, and make a defensible choice for a specific use case. We also cover why models can sound confident while being wrong, and what you can do about it. Think of a model like a very advanced autocomplete engine that learned patterns from large amounts of data. During training, the system adjusts internal values so it gets better at predicting. During inference, it uses those learned patterns to generate an output for your prompt. In academic learning settings, model selection should be tied to the task, risk level, and data sensitivity. You should never use an open, public AI model for sensitive or proprietary information. If your academic institution provides an enterprise AI with a secure API, such as a secure copilot, then this is what you should be using for schoolwork. The same with your employer. If they provide a secure AI for your work, you should not put organizational information in any other AI model that is open to the public. By the end of this section of the video, you should be able to describe what a model is, recognize the most common model attributes you'll see in product menus, and make a defensible choice for a specific use case. We also cover why models can sound confident while being wrong, and what you can do about it. LLMs are built on transformer architectures. In other words, it predicts based on its training what will come next, and therefore, it gives you what you are asking it to produce. For example, if I type peanut butter and you already expect jelly, and that's the basic idea, but the model may give you peanut butter and bananas, a popular snack. LLM predicts what is most likely to come next. It generates text by selecting the next most likely word or token in a sequence based on patterns learned from large amounts of data. Because it works this way, LLMs are excellent for drafting, summarizing, and explaining. But the same prediction process also means they can produce information that sounds confident and believable but isn't accurate, sometimes called hallucinations. Key takeaway: fluent, polished writing is not the same as verified, evidence-based facts. So always double-check important claims using trusted sources. Here are a few quick terms you'll see in AI tools and why they matter. A token is a small chunk of text the model reads and writes. Tokens are vital because they limit the amount of content you can paste into the AI model and determine its response length. The context window is the model's working memory, how much text it can consider at one time. This matters because if your document or conversation is longer than the context window, the model may miss earlier details. Parameters are the model's learned internal settings, basically where it stores patterns from training. More parameters can help with capability, but they don't guarantee accuracy. Training is when the model learns patterns. Inference is when it uses those patterns to answer your prompt. Tool use or agents means the model can call outside tools, like search, calculators, or databases, to finish a task. Grounding or RAG means the model ties its answer to provided or retrieved sources, which helps reduce made-up or unsupported claims. Using an LLM is conversational. First, you give the LLM instructions and context, your prompt. Upload any files you need to attach, and reference any previous conversations within the same chat link. One setting that affects the output is called temperature. Think of temperature as a creativity dial. A lower temperature makes the LLM more consistent and cautious. It tends to stick to the most likely wording. A higher temperature makes the LLM more varied and original, but it also increases the chance of unexpected wording or mistakes. In academic or professional writing, where accuracy, consistency, and a neutral tone matter, lower temperature is usually the safer choice. For casual brainstorming, a higher temperature can be helpful. Finally, some LLM systems can use tools. When tool use is enabled, the model may retrieve sources, run calculations, or pull information from a database before it drafts the final answer. This matters in school and at work because using tools and sources helps the output be more evidence-based and easier to verify. The AI ecosystem includes application plugins and multimodal features that many students find engaging. I encourage students to experiment with these tools to discover which options best support learning, research, and stronger writing. Multimodal input means an LLM can work with more than text. Depending on the platform, it may also interpret images, PDFs, and tables, and sometimes audio or video. Projects and workspaces function like dedicated folders where you can keep your prompt instructions, files, drafts, and goals organized in one place for easy reference later. In video 6, for this series, we will discuss AI agents. These can be created for personal use and can serve as an efficient partner for handling repetitive tasks within an LLM platform. Finally, it is essential that students follow their institution's academic integrity and privacy policies. Students must also follow course policy, cite or disclose AI use when required, and never upload restricted, proprietary, or sensitive data into a public AI model. As mentioned, LLMs can be helpful and still be wrong, especially without prompting for evidence-based and reliable primary sources. Have a frank conversation using well-written prompts to avoid its central limitation hallucination, outputs that are fluent but not factual. Enterprise and business AI systems are preferred over any open public AI because they emphasizes risk management and governance for their AI systems, especially in high-stakes settings like an educational institution or a place of business. First, an AI language model is a prediction engine, so it can write fluently, but it can still be wrong. Verify anything important. Second, your results depend on what you give it. Provide clear instructions, the right context, and, when possible, your sources. Third, tokens and the context window set the limits. If the model doesn't see it, it can't reliably use it. Fourth, use the right settings for the task. For academic and professional work, keep outputs consistent and evidence-based. For brainstorming, you can allow more creativity. Finally, explore the ecosystem. Plugins, tools, agents, and multimodal features. But stay in control. You are responsible for accuracy, privacy, and academic integrity. In the next video, we practice prompting patterns that improve clarity, reduce errors, and support verification. References. Hope this was helpful, and thank you for watching.